see something, but we'll have more for you later in the broadcast. Dwayne.
Thanks, Sean. Hopefully you can use some of your connections to get us some good weather here in Charleston. So the moon is already moving across the face of the sun. We're getting close to viewing our first total eclipse of the day. We're minutes away, and remember, the total solar eclipse starts on the west coast of the United States in Oregon, and we will be bringing you live images as it occurs. NASA's Ames Research Center's Jesse Carpenter is standing by in Salem, Oregon at the Oregon State Fairgrounds. Jesse, give us a status report.
Oh, wow. Thanks, Dwayne. Totality is almost here. Oh, this is so exciting. And just before we get to that, though, I want to introduce Andrea Edgecombe again from the Oregon Museum of Science and Industry. Hey.
Hi.
So tell us a little bit about this really fun, cool viewing event that's going on here.
Yeah, well, we are here. We have almost 9,000 people here at the Oregon State Fairgrounds, and we've had some cool stage presentations. We heard from NASA astronaut Don Pettit. He's an Oregonian. We had a University of Oregon professor. And behind us, we have some space science partners who've been doing some cool educational activities and really interacting with the crowd. So it's been an awesome morning, and we can't wait for totality in a few minutes.
This is such a great event. Thank you for joining us again. We really appreciate it. I know you got to get going.
Yeah, so thank you.
It's coming soon. And joining us now to talk to us about the sun and give us more information is NASA lead scientist for Eclipse 2017, Madhulika Guhatakirta from Ames Research Center. Hi, Lika.
Hey, Jesse.
Hey, it's almost here. It's almost here. So how many eclipses have you seen?
I went to see 9 eclipses, and I actually landed up seeing 6. The other 3 had inclement weather.
Oh.
We don't have that here today.
No, we don't, and it's going to be 7. So what can you tell us about the sun that'll help our audience understand better?
I just want to start by saying I'm in awe at this moment right now. And whatever I say, kind of take it with that filter, because we are very close to totality.
We are.
We live in the outer atmosphere of this magnificent, dynamic, magnetically variable star that dominates every cubic inch of space in our solar system. And if I can get the video, what you would see in the video is that the sun produces storms that can be all engulfing, generating this environment called space weather. The inner edge of the corona that you see that's black in the video is because the sun is so intense that it overwhelms the dim brightness of the corona. And so even from space, we can't absorb the inner part of the corona. And not only Earth, but the entire solar system, as you can see, lives with this dynamic star. Corona is the region where space weather is born and conditions are set for a supersonic solar wind and a super hot corona, 2 of our outstanding questions in heliophysics, in physics, really. To understand the corona better, NASA is actually going to be launching a mission next year, almost a year from now, how coincidental, called Parker Solar Probe. It is actually going to go touch the sun, and it's going to get closer to any other spacecraft has gone before to the sun to study the corona, to actually sample the very corona that we will be seeing very soon.
Yes, we will. It's almost here. Thank you, Lika, for joining us, and thank you for sharing that. So now we're going to take it back to NASA Eclipse Central in Charleston. Take it away, Dwayne.
Okay, just now coming in, we have an exclusive sneak peek of the total solar eclipse, and it is arriving at the United States. It's over the Pacific Ocean and about to reach Oregon. This is the celestial event that we've all been waiting and anticipating for years. We'll begin looking through the eyes of NASA out the window of our G3 aircraft. Let's take in the view.
Wow.
And now we're looking at the first glimpse of the total eclipse from the ground. Wait, let's see. That's still the G3. There we go. And now we're looking at the first glimpse of the total eclipse from the ground on United States soil. This is coming to us from Salem, Oregon. where thousands of people are gathered and experiencing this monumental event, a total solar eclipse. Let's take a look and take in the view.
Qué guapo, loco. LOL.
That's the G3 there.
LOL, y aquí todavía no pasa, eso en Estados Unidos. Loco. Qué guapo. Mira eso. No te preocupes, Brain, aquí va a ser un 25% en su totalidad. Loco, qué guapo, mira eso. LOL. Qué hermoso se ve, loco. Mira eso. Buah. Buah, chaval. Mira eso. LOL. Lo estoy viendo desde el espacio, ¿no? ¿Se supone? Loco. Mira eso, loco. Qué hermoso. Miren, ¿ven esto rojizo? Son los valles de la luna. ¡Mirad esto, mirad esto!
Okay, so
LOL.
As the moon has now moved, the sun is appearing again, and we can see the diamond ring. It's amazing. It's fantastic. You see the outer edge. I see prominences. Little red pieces of
Mirad, que parece un
chromosphere from
anillo.
the lower atmosphere. This is amazing. This is absolutely amazing.
Jody, what we got?
¿Tampoco
That
está
looks
duro, en
pretty
serio?
cool.
I mean, it's breathtaking. I just, even seeing it right now through the TV, it's just an amazing thing to see. I cannot imagine what we're going to feel here in South Carolina when we have our chance.
Well, I hope we have our chance to, you know, Sean, and, you know, get that weather up here looking good here in Charleston.
Wow.
Now, what do we,
So Alex,
Alex, what are we seeing here?
Is that from the G3?
Wow.
That looks like from the G3 because I see spectra there.
No, it's still from Salem.
That's still from Salem.
Yeah.
Okay, so you're seeing the bright. Actually, the camera is causing a little prism effect there, and you're seeing the bright light from the edge of the sun.
Lo que pasó fue desde el
So that
espacio.
is really beautiful.
Ahora
That's sort of the edge
falta
of
desde
the
la
diamond
Tierra.
ring effect.
Yeah.
So Alex,
Now-
a reminder, Alex, so when that diamond ring pops up, that's what people should put the
That's
Yes.
when people should put your glasses back on. So when you see that diamond ring after totality, that's
que
the
mola.
signal to you that it's time to put it back on.
Yeah.
So look now, we see the corona in Madras. That's gorgeous.
That's amazing. I
Yeah.
mean, being able to look at that with your own eyes is an amazing experience. And that only can be seen when you have this kind of totality.
So the corona, that's the
The solar atmosphere.
that's what solar scientists really live for, right?
Right.
Yeah.
Right. That is the origin. That is where the origin of space weather.
Yes.
That's where it
¿Veis
comes
la,
That's where
la
most of the
atmósfera
solar
de aquí?
flares, the
Mirad.
coronal mass ejections,
Eso es
big
el sol.
explosions of particles
Ese
originate
es el
from.
verdadero color del sol.
Now,
Es-
solar activity, we see it right now. Would you
Mira
be able to
de
see
esto,
that
loco.
popping up on the sun?
If there was a coronal mass ejection leaving the sun, we could see
We
it
could see
there
it.
because in fact we have seen it in the past, and I'll even show some history later with images that people drew of these coronal mass ejections leaving the sun during a total solar eclipse.
Now, why is it so critical and so important to really get this type of view from the sun's atmosphere from the corona? Johnny?
You mean like in a total solar eclipse?
Yes. There's the diamond.
That's
There we go.
Mira,
otra vez
that's
el
amazing. That's the
diamante.
madras.
Wow.
It is important to do this because we do this kind of eclipses artificially, but we do
Mira
not do it
eso.
as perfect as nature does. The moon covers the sun in such a perfect way that we see parts of the corona that we don't usually see.
So Alex, explain that and safety too, right?
So right now, this was the moment when you see that flash of light. That's the moment when it's time to put your glasses back on or start using your indirect methods, because now it's too bright and it could damage your eyes.
Yeah. Safety first, people. Always.
Wow. So the folks in Salem, Oregon, I mean, they're like
Loco.
juice. I mean, they got it. They got the good.
They've got a perfect view, and they are seeing one of nature's most amazing spectacles.
I can only imagine the reaction on the ground from the folks there.
Oh, they are probably
Gasping.
completely overwhelmed right
Yes.
now. Completely overwhelmed.
Well, I certainly hope we get something like that. But we've got it here on NASA television through the eyes of NASA. And we got the International Space Station coming up and other images only we can bring.
Only
That's
NASA can bring, yes.
Uy, me tapó la pantalla. Qué hermoso.
Now, is it
qué hermoso.
completely dark or is it coming out?
No,
It's
what's
coming out.
happening now is the filters are back on, the safe solar filters for the telescope, and now you see the crescent, which is the sun, basically
qué hermoso,
now
qué hermoso.
being revealed after the eclipse. So we're now back to the partial phase
Yes.
in the other direction.
Exactly.
Now, how fast is this going?
Well, this shadow is passing across the country, depending on where you are, anywhere from 1,200 to 1,800 miles an hour. So this is moving incredibly fast because the moon itself, in its orbit, is moving at almost 3,400 miles an hour. And
El que
that,
estoy hablando
in
soy yo.
combination with the rotation of the Earth, is what gives us a shadow moving that fast.
Okay, so Gotti, let's talk about space weather. Seeing this and space weather is so important. So just let us really understand why it's important on space weather.
No se
So
preocupen, yo
space
tampoco
weather is
sé
pretty
inglés.
much the conditions created outside in space due to the sun. We look at space weather because we want to understand these conditions. If you look at the image that you have now, you're going to see SDO image, the Solar Dynamic Observatory. That's
Chicos,
where we actually look
simplemente,
for the source of
es que no hay
space
que
weather, where
traducir.
the solar flares and the corona
Lo que dicen
projections
todo el
actually
tiempo es que hermoso.
originate from.
Qué hermoso. Qué hermoso
Well,
eclipse.
when we look at SDO, at the images, we also have to look at artificial eclipses, like the one that you're looking at online now. These are actually from the SOHO spacecraft. These are the artificial eclipses that I was talking about, Dwayne. Like this, you have to block the solar surface to be able to see the solar atmosphere, the outside corona. But you're gonna see something like this today, and you saw it. But you're gonna see it better because nature does it better than we can actually do it artificially. Right now, the activity is there's not too much going on in the sun. However, if I do a historic event, which actually was from this past July, you can see a coronal mass ejection, this big explosion of particles that come from the sun.
Well, those look pretty intense. Do we have to worry about that? That doesn't look good.
Well, you know, space weather, what can actually do is affect communications. We have the magnetic field of the Earth to actually protect us. It's our shield. And what we do is we actually can analyze that using real-time models like the one that you're seeing on the screen, that we actually understand how the magnetic field of the Earth changes with those coronal mass ejections. But space weather can affect communications, satellite instruments, and power grids.
Okay, so we're going to toss to Idaho. And I think we've really got some good stuff here. Gay Hill, are you there in Idaho Falls? Idaho Falls?
I am absolutely here, Dwayne Brown. In fact, looking through the glasses right now, it's so weird. We have a crescent sun instead of a crescent moon. This is I think we haven't had a total eclipse here in Idaho Falls
¿Por qué aquí no venden esos lentes? Nada más allá.
128 years ago, and things have certainly changed in Idaho Falls since then. There's a whole lot more people, especially with all the visitors in town. We're just outside the Museum of Idaho, and we have partnered with the museum to make this an official viewing site for Idaho. And they right now have an exhibit on space, but we also sent in a team of experts. And for the past 3 days, we've had talks, we've had demonstrations, we've shown them visualizations such as eyes on the solar system, and we've shown them artwork. But really, the order of the day is the eclipse, and NASA has that covered too. They have sent an army of volunteers. We call them Solar System Ambassadors.
Hola a los nuevos, y que por cierto, eso fue hermoso.
And they're volunteers. These are people just telling people what they're seeing and helping them understand. We have one here, right here. His name is Richard Stember. Hey, Richard. He has been manning this mobile observatory, and that is what is providing our solar telescope shot right now. Now, we asked him, what's it like being a solar system ambassador? And he said, follow along. We did, and we went with him to a school in Southern California. Take a look.
Sí, estaban explicando que hay un observatorio, que están viendo el eclipse y no sé qué. Y se queda sin sonido, perfecto. Se le cortó el sonido a la NASA.
I apologize, there is no audio on that video, but it talks about the solar system ambassadors. There are about 720 in the United States. They get special training from NASA. They learn all about the missions and about the science, and they basically go out to public events all over the country teaching them about NASA missions. If you would be interested in becoming a solar system ambassador yourself, you can. We have a website, look it up, Solar System Ambassadors. It is a NASA website, and starting September 1 through the end of the month, you can sign up to be a solar system ambassador. So check it out on the web, Solar System Ambassador. With me now is Jim Green. Jim Green is the head of planetary science for NASA. He's in charge of all planetary missions and asteroids. This guy knows his stuff. Let's talk about this. Now, you see this eclipse that doesn't happen. It happens once in a lifetime.
Wow.
But as a scientist, you see it as an opportunity.
Oh, absolutely. I mean, we're getting the eerie feeling right now, but when we launch balloons, and there'll be 57 balloons along the path, 30 of which are going to have a planetary experiment on them.
And we have video of this. Now, just a few days ago, we had a crew here. They did a test launch for us, and they sent up an imaginary payload for us just to see how it all works.
En realidad ya pasó el punto máximo en el directo, así que bueno, esto ya
We have a bacillus. It's a harmless bacteria. We have on 30 balloons 2 coupons where the bacteria will be sprayed. One will stay on the ground, one will be affixed to the balloon. It then will go up to 100,000 feet above the ozone. So the ultraviolet light, also blocked a little bit by the moon, is just like Mars. In addition to that, the temperature and pressure will be just like Mars. So when the balloon goes up higher and bursts, comes down, we'll retrieve that coupon off the balloon, match it with the one on the ground, and then we'll see how many survive.
Now, why is that information so critical for Mars research?
Well, this bacteria is pretty much everywhere. It's very hardy, and it probably has made its way to Mars, perhaps even on our rovers. And I would like to know if that environment is so harsh that it would eliminate that bacteria or not.
All right. I'm being selfish. I have never seen a total eclipse. And I'm sorry, I would love to talk to all of you people, but I want to put on my glasses too and take a look. Can we continue this conversation?
I have to do this too.
All right, and watch, and we can talk. All right,
Oh,
so
what
we
a little
still
sliver.
Just a little sliver of the sun right now. And let's talk about this. Why is this so rare?
Mirad como en Idaho es totalmente de noche, loco.
Tilted by 5 degrees, and so there's only 2 places where the moon and the Earth and Sun are on that same line, and that's why every 18
Aquí será
months or
como a
so
la
we
1 y
get an
tanto, fe,
eclipse.
que ya me empieza aquí, ¿eh?
1 minute away. Wow.
The crowd is getting excited.
Wow. It's already so
Oh,
eerie.
wow, it just got dark all around us. And you can feel the temperature getting colder
Oh
here.
yeah, the winds are really picking up. You know, this dark area, the winds are just flowing in.
Oh, you can, it's just a tiny, tiny sliver right now. It's all closing up.
There it goes, it's going, getting smaller.
Oh my gosh!
Oh, look at the ray structure. You can't get that on film. There's Venus.
Oh wow!
There's Venus.
LOL. ¿Han visto cómo fue? LOL.
Oh, wow. Wow. Oh, look at that ray structure.
You were saying this is the only way you can see the atmosphere.
Yeah, that lower part of the corona is really even hard from space to see. Wow. Wow. I got to spend a second looking around at the crowd. Oh my goodness. Yeah, wow. Wow.
We should turn off the lights.
All right, have to get ready to put them back on here soon.
Okay.
Pretty quick.
Have you noticed, Jim? The street lights are all on
Oh, the
around
street
us.
lights turned on,
We
of course.
confused the street lights.
Of course. Who would have thought that? We didn't plan that one.
All right, we should get ready for our glasses again. Get ready with your glasses.
Okay, there it goes. There's the
Stand by.
diamond ring. There's the diamond ring.
Oh my gosh.
Yeah, wow.
That is
Was
so.
that all right?
Oh my gosh. Whoa! Oh, that's brilliant.
All right. Wow.
Okay, glasses back on.
Too brief. Too brief. Too brief.
Okay. We're going to have to wrap this up pretty soon, Jim. That was incredible.
Way too brief.
Yeah.
Way too brief.
We got a minute 50 seconds.
Yeah.
That was all we had. Why is it that some parts of the country get a little more than we do?
What has to do with the curvature of the Earth also. And so the shadow is at various altitudes. You could go up at a higher altitude and get all.
Que es totalmente de noche, loco.
So Idaho Falls has had its total eclipse. The next one is coming in 2252. We won't be here, but we hope NASA will. Back to you.
Well, Gay Hill, that's Gay Hill from NASA's Jet Propulsion Laboratory. Gay, I'm jealous. I'm telling you, I'm jealous. So Alex, explain again that diamond.
Well, so the last bit of sunlight, when you see it at the very beginning, is when the last bit of the sun, the crescent, shrinks down to a little tiny bit, And at the same time, you can see a ring of the corona around it, so that makes the ring, and then that bright bit of crescent gives you the diamond. So when it reappears, you get the same thing. The last bit of corona is a ring. The flash of the sun is the diamond, giving you the diamond ring. It's a beautiful, beautiful sight.
And real quick, and then I'm going to ask you a question because there was something going on here in Charleston. The planetary, Jim Green said something about Venus. This is really cool for planetary science because you can see other planets, right?
Absolutely, and as a matter of fact, one of our missions through the WB-57 aircraft are studying Mercury, which is very, very close to the sun.
Sí, intentaré grabar algo, pero es que va a ser parcial, tampoco va a ser completo, ¿sabes?
NASA is ready to take a bite out of the Big Apple, one of my favorite cities, Jody, New York City. New York City. Today's broadcast is being shown, I believe, in Times Square on the Toshiba Vision screen, so the city can also enjoy the spectacular views of today's total eclipse. And we've got a great relationship with Toshiba, so a shout out to you guys. This Midtown Manhattan tourist location is always bustling with crowds. On the average day, over 300,000 people pass through Times Square. Alex, I'm going to turn to you. You know, New York, they're going to get a partial, but they have a rich history in solar eclipse.
They really do. So actually 92 years ago, on a cold January morning, New York City, Manhattan, and Queens experienced a total solar eclipse. The edge of the path of totality went from 95th Street to 97th Street. This was an amazing opportunity. This was the first time we sent up 2 dirigibles with the U.S. Naval Service for scientists to study this. At the time, we actually thought eclipses could be creating radio waves which mess with communication. But what in fact is happening is the sun itself is creating this disturbance. So studying the eclipse is actually telling us about the sun, which is creating these disturbances here on Earth.
Yes.
Okay, so this just in. I believe we have results from an experiment that occurred on NASA's Gulfstream 3 aircraft from NASA's Armstrong Flight Research Center. Karen Rohr is standing by with Thomas Zabukan, the Associate Administrator for the NASA Science Mission Directorate. Let's go now to see what the instrument observed during the total solar eclipse. Kevin.
As ready as I'll ever be with this.
And we're back here at the G3 up over the Pacific Ocean off the coast of Oregon. And it was amazing, wasn't it?
It was outstanding.
And so for me, like, you know, at 25 years I did research on the corona. I saw it for the first time. It was my first eclipse. Was it your first eclipse?
My first eclipse as well.
Just absolutely amazing. And I want to talk about 2 things. First of all, the shape of the corona. You know, I saw the models. I showed the model, and it was remarkably similar. You know, I saw these streamers, these magnetic structures coming out like glows in specific directions, just like we expected. So I'll look for the analysis before we claim victory, of course. But the other one is that spectrograph you, Mike, you know, ran on board. And just before that the sun, you know, disappeared behind the moon, that spectrograph, of course, is spreading out the light in all its colors. Just before it disappeared, there is that one shot. And Laurie, I want to ask you whether you can turn it on. Do you see those specific kind of lines that pop up between the green and the red? It's just like we said, it's helium. Remember, that's how it was discovered, helium. We didn't know we had helium here. It was a new element. It was discovered that way. And then over there in the red, between the green and the red, is iron. Iron, a really hot iron, telling us that, hey, this atmosphere is really hot. And then a little bit over, it's another line, red. Well, what is that? Well, it's hydrogen.
A ver, ¿de qué me perdí?
So even though it's really hot up there and only 1 in a million or 10 of million particles are neutral, it's still visible in that one shot that you saw. So Robert, back to you here, back on Earth. What did you feel like? How did you see this occur?
Yeah, so it was fascinating to watch actually the shadow or the path of totality underneath us. We're at 35,000 feet, and you could see at totality, you could actually see the darkness down on the ground. And you could look north and south and see where it wasn't completely dark. And as we kept going, you could just watch that darkness move. It was almost like a thunderstorm moving across the plains, but it was all the darkness, and it was just stunning to me to see that. So really, really good stuff, and I wasn't expecting that. And of course, the eclipse itself was beautiful, but seeing what happened down on the ground level of Earth from 35,000 feet was amazing. I just got to tell you, the team on this plane and the team all the way around this country is just doing a fantastic job. I wish you could have seen the folks here working to make sure we got the data that Thomas showed, some fantastic images we've already looked at that I can't wait to share with everybody and for everybody to see. But
Ya mero empieza
really
aquí,
excited
qué
to watch
emoción.
this team work, and the pilots did a great job. We had a little bit of a challenge right at the time of when we needed to be best, but they did a great job recovering from that, and then kept us on path all the way through. So anyway, so thank you guys. Remember to put your glasses on for those of you who hadn't seen it yet, and we'll talk to you soon.
Fantastic stuff. And if you just tuned in here, you're watching Through the Eyes of NASA, NASA television. We have the best views of the solar eclipse today and coming later in the show. You don't want to miss this, the International Space Station live. Now, next up, let's visit a working farm at Austin Peay State University in Clarksville, Tennessee. Agricultural observations and solar eclipse viewing activities are underway, including high-altitude balloon launches and painting cows.
Painting cows? What?
Okay, all right. So now let's go to the NASA Marshall Space Flight Center. Chris Blair standing by.
Well, humans are naturally excited about the solar eclipse, but one thing we've learned on this working agricultural farm is that animals can as well. But more on that in a moment, as right now we're getting ready to do a live scientific balloon launch. And joining us to tell us more is Dominic Critchlow from Austin Peay State University. Thanks for joining us. We appreciate it. So tell the crowd and our audience a little bit about the scientific payload you have on board.
Yeah, thank you for having me. Today we're flying some still image equipment, and we're going to be taking images of the ground in different wavelengths. And we're also flying live streaming equipment, so we can live stream the eclipse looking downwards and looking around and at 100,000 feet, which is higher than any plane has ever gone. We're also flying some biological samples with NASA Ames and then our trackers so we can have a successful recovery.
Okay, and they've just released your balloon. So let's talk about the NASA science and the biological samples. Explain more.
So NASA Ames has contacted us and all of the other teams that are going to be doing launches today across the whole path of the eclipse. We're going to all have a little chip of biological samples on today across the whole path of the eclipse. We're going to all have a little chip of biological samples on there that are going to go up in the stratosphere, which is a similar atmosphere as we would see on the Martian surface. So we're doing some Martian studies, which is really interesting and cool.
We are very excited about that. And so also, how many balloon releases are you planning on doing this today or this weekend?
And so all across the U.S., we have about 50 teams that are launching in the path of the eclipse so that we can have a full coverage of the stream. And on the site today, we have 3 launches from 3 different universities. And we're just really excited to be here and hopefully all successful launches.
All right, so finally these balloons do go up and they come back down. And so what's some advice if anyone finds one of these payloads out and about across the country, what's a tip you would tell them?
If you find it, leave it there. Maybe take a picture because it's kind of cool to see something land in your backyard from research. And please don't touch it. We'll be there soon to pick it up. If you have to move it, let us know, and we'll just be there to recover it.
Awesome. Thanks. We appreciate your time.
Thank you.
Appreciate it. Okay, so yesterday we had a chance to catch up with some serious students, albeit a little younger, but serious about doing real-world science nonetheless. And here to tell us more is my good friend and colleague, Mitzi Adams from NASA's Marshall Space Flight Center in Huntsville, Alabama. Mitzi, thanks for joining us. We appreciate it. So tell us about the science that these high school students are working on.
Well, the students are actually working on some atmospheric science experiments. They're doing animal study experiments, and they're helping us observe the sun in various wavelengths of light.
And these students aren't just from the Clarksville area. I understand they're all around the country, if not perhaps the globe.
The students are from the U.S. Space and Rocket Center, and yes, they are from all around the globe. And they're actually from the Inspire project as well. They're participating in VLF radio noise experiments, and those folks are from Washington, D.C.
All right, excellent. So you mentioned the Space and Rocket Center, Space Camp. That's the official visitor center for NASA's Marshall Space Flight Center. Feel free, if you're in northern Alabama, to come and see us. They do a great job of representing a past, future, and present history of NASA. So any parting words?
Well, you know, in the words of Frank Reynolds, I'd like for us to remember for the next American eclipse in 2024, let the shadow of the moon fall on an earth at peace.
Very poetically done. We appreciate it. All right, so up next is, as promised, our animal lovers segment. And so here on the agricultural farm, students are studying really cool STEM fields. So it's conservation management, it's veterinary medicine, animal biology, and so they're interested in animal behavior. And so joining us is Dr. Donald Sudbrink, head of the Ag Department here at Austin Peay State University. And so it's not cow tipping, it's cow painting, correct?
Yes, we had to paint the cows.
Bueno, voy a dejar esto por aquí porque ya mero empieza aquí. Aquí ya mero empieza. Adiós.
So we saw the cows
Aquí ya mero empieza.